to the Insightful Professor. Today's QuickStart video is entitled Introduction to Database. In this video, we'll provide a high-level overview of a database system. The primary objectives will be to prepare you for using a database and also to understand additional aspects of database systems, which we'll address in future videos. This video introduces some of the common terminology associated with database. It also describes two types of systems that you might encounter in a business or organization. One is an operational data store, also called a transactional database, and the other is data warehouse. As important concepts are presented, the individuals who use or support a database are going to be identified to you by job function. This will help you understand who does what within the organization. So let's start off with the first question. What is a database system? Well, we can see that a database system could be thought of as an electronic filing system. If you look at the filing cabinet over here to the right, what you'll see is this is going to be the way we're going to relate the concept of hopefully something you already are familiar with something that you're learning about, database systems. So the operations that you perform on files and file folders would be similar to what you would be doing with working with data within a database. You're able to store the data for efficient retrieval. You're able to retrieve specific data. That is, you don't have to retrieve the entire file cabinet to find some piece of information. You request a specific piece of data, and you get that, a specific file folder. You can modify existing data. So that means you have the ability then to pick up a file folder about whatever the individual or topic is, make changes to that, and then store the updated version back in the cabinet. Same concept applies with working with data within a database. You can remove what's no longer needed. So for example, a particular file or folder is no longer relevant. You can remove it from the cabinet, discard it, and it's gone. Another thing to recognize is what we store in a file cabinet is often considered confidential or perhaps has to be protected in some way. It might be sensitive information. Same is true of data that we entrust to a database system. So what we're looking to do is to provide some security similar to what we have for locking a file cabinet. Database systems provide those capabilities as well. Now, the individuals who work with databases, such as application programmers or developers, serve to write these programs that perform the operations of these first four bullets that we've identified here: storing, retrieving, modifying, and removing the data. That would be data retrieval and data manipulation. Well, with that behind us, let's take a look at the next step. What is a database management system? Well, a database management system, often called or abbreviated as DBMS, is a software system that enables the use of a database or a database approach for storing and managing data. Now, the DBMS is a piece of software that you'll be running on a computer. And what we'll see is this serves as a middle layer or an interface between us in the front end and the database being stored on what's called the back end. So what happens is we might write a program in a language such as C or Java or COBOL, any kind of a programming language, and that program does not directly communicate with the data, but it funnels its request through the DBMS. The DBMS then accesses the data and returns the result to the program. Well, what happens if you're not a programmer, but you're, say, an analyst or a business user? Then we have another interface. We still issue our requests through the database management system or the DBMS. However, the way we submit these requests is typically through some kind of an interactive type of tool. For example, what we'll see is if you were using Oracle database, you might see a tool like SQL Plus or SQL Developer. If you were working with SQL Server Management Studio, then you might have a tool such as if you're working with SQL Server, the tool you might have is SQL Server Management Studio. Other vendors, such as Quest Technology, provided a tool such as Toad. So there are various types of interactive tools through which we can communicate requests to the DBMS. What's the benefit of these tools? Well, you don't have to know how to program in a programming language like Java or C. You simply have to have knowledge of the basic commands that the DBMS recognizes and can subsequently act upon. And that's something we'll address as we get a little further into our videos. So what kind of DBMS products are out there? There are many. We'll be talking primarily in our lectures about relational database, and we'll describe what that is in one of the next videos. Products such as Oracle Database, MySQL, SQL Server, Access, DB2. These are all database names that maybe you've heard about, depending on where you hang out. You might hear about it in the office. You might hear about people talking about these on the street. These are some of the big players out there. Now, another job function. A database administrator, also called a DBA, may be the individual who installs the DBMS software and subsequently maintains that software. Now, some more terms. This is one of the challenges of getting started with database and becoming comfortable in that world. There's a lot of terminology out there. So we have definitions here of data and information, and before we get into that, we talk about a concept of what's called data persistence. This is a very important concept. When you're running a computer program, and many of you have probably run a program such as a word processor or a spreadsheet, when you're running such a program, that program is working with data, manipulating data within the main memory of the computer. What happens if you turn the computer off before you saved your data, or the computer locks up and you have to reboot it? Well, whatever you were working on is lost. The point is that the data that you manipulate in main memory, it is not going to survive the execution of the program through which you've been manipulating that data unless you persist the data out on disk. You save the data so it survives beyond the execution of the program. That's the concept of data persistence. So a database provides a way of achieving this very important goal of data persistence. Okay, now with that behind us, what do we call data? How do we define that? Well, data could be considered stored representations of meaningful objects or entities or events within the world that we're dealing. So sometimes we think of the data more as something like just raw facts. The fact that you went to a grocery store and purchased, say, a gallon of milk, a loaf of bread, a jar of peanut butter, those were the items purchased in a single transaction or single event. That will be recorded. That's data. That's just raw data. How can we use that data to make sense and perform meaningful business tasks, kind of guide the business, grow the business, or adjust the behavior of the business? The data itself doesn't really make that possible, but interpreting that data, providing the context in which that data came in, we produce what would be called information. So the information results from examining and processing these raw facts. And the information is how we can then become better informed and make effective business decisions. So the type of data store or repositories that we'll be talking about would be an operational data store, sometimes called a transactional database, and that goes back to where we just visited the grocery store and made our purchase. That was a single transaction. So suppose we have three people in line, Mo, Larry, and Curly. Mo makes a purchase. That's a transaction. Larry steps up to the register, buys a couple of things. That's a separate transaction. And likewise, Curly makes a purchase, a third transaction. That's what an operational data store is going to record, kind of the operational data, the transactional data that has occurred. But for decision making, we often will want to record all of that information and look not at just what Mo did or what Larry did, but we want to say, well, what transpired in this day, this particular day, looking at a particular day, a particular week, some kind of time period. We have what's called historical data. So we're not just looking at current data. See, an operational data store will store Current data, historical data, is stored typically in something called a data warehouse. Now, the nature of this data is quite different. We perform things like time-based analysis, such as I was suggesting, where we're looking at everything that's transpired over the course of a day. So what were the total sales during the day? Or how did we do in the first few hours of the day? Or how did we do at midday? How did we do in the evening? We're looking at time periods where we're looking at an extended amount of activity and kind of summarizing and analyzing that. We can also look at something called trend analysis. For example, how were sales today versus sales yesterday, or sales this week versus sales last week? So we can do some kind of comparative analysis. That's what data warehouse allows us to do. So these data stores separate the analysis workload from the transaction workload, and they enable organizations that have such data stores to consolidate the data from several sources and put it into our data warehouse for analysis purposes. Now, the individuals in the organization who will be doing this kind of business decision making might just be simply called users, or they might be called analysts. Now, one of the real key aspects or characteristics of a database is a database captures relationships. The relationships have different cardinality. The cardinality refers to the number of one type of thing that participate in the relationship and how many of that other thing. What's the number of the other thing that participate? Typically, we have what would be called a binary relationship, two things involved. So we could have relationship cardinalities of one-to-one, one-to-many, and many-to-many. Now, the key, though, is before we can use the database, someone has to design it. And the database becomes a representation of the world. And unfortunately, the world is sometimes, maybe often, a very complex area, a complex, say, realm. And the complexity, in order to be able to understand it, illustrations come into play, diagrams. So very often we'll see a database being designed by first building an entity relationship diagram. It's just kind of like a builder will build a house, not just by saying, well, I think I'll slap this board together with this board, put a couple nails in there, but they have some kind of blueprint to guide them as to how the house should be organized. The blueprint was constructed before the construction of the house began. So the entity relationship diagram effectively serves that purpose of describing the relationships, the entities, how they're associated, and so forth. The individual who performs such a task, this individual might be called a database designer or a data modeler. Now, the relationships that we talked about with cardinality, here's a quick illustration. One employee parks in one parking space. A parking space, say, is assigned to one employee, so that's a one-to-one. We could also have a one-to-many. A product line contains many products. Also could have a many-to-many, where we say many students register for many courses. Understanding the cardinality and recognizing not only the relationships but the cardinality is one of the tasks that the data modeler has to address. And he or she acquires an understanding of what we call the application domain, the world that's of interest to us that we're going to model and subsequently represent in the database. In acquiring that understanding, that can sometimes be a challenge. Now, an additional challenge that we're faced with database is the sheer quantity of data that we tend to have to deal with. It used to be in the good old days, we might have talked about thousands of bytes or maybe millions of bytes as being big, but nowadays we see that we are faced with huge quantities of data. And this becomes a challenge not so much for designing the database as it is for using or working with the database and being able to do our things like data retrieval in an efficient manner. So we're often faced with large corporations having megabytes or millions of bytes, gigabytes, billions of bytes, even terabytes or trillions of bytes of data. And when we get into data warehouse where we have historical data, then we might go with terabyte, petabyte, exabyte. Huge quantities of data might be out there. So very large decision support systems, which is what database warehouses might be used for, may be implemented in such a way with these enormous quantities of data. So what is it that we've talked about? So as we conclude the video, let's take a quick look. We've provided an introduction to database systems, defined some of the common terms that you might encounter and need to know in understanding and working with databases. We presented some of the key characteristics of database, and we distinguished operational from informational data management. We also explained the roles of individuals who work with databases. So I hope you found this helpful and informative. We've covered a few topics here. We're going to cover more in future videos. We welcome your comments, so please offer any comments or suggestions and consider subscribing to the channel. And once again, thanks for watching.